Good morning. I am Gopika, the BCC section. My project guide name is Miss Sharon Dominic. My project title is Predicting Cataract Eye Disease Using Machine Learning. In the first, we see about an introduction. In the introduction, a million of people worldwide suffer a cataract disease, which are one of the main causes of blindness, especially at people ages the people age. Clouding the natural lens of the eye, known as a cataract, can result in reduced vision, and if untreated, the eye will total blindness. So the main purpose of this project is we use the machine learning model to previously to forecast the individual risk of developing cataract based on the variety of data input in the eye image to predict to train the machine learning model and predict the eye. So if the main purpose of the project in the to create to create a machine learning model in CNN method. So first we see. Next, the problem statement. Statement in the project. One of the most common causes of the blindness is cataract. Currently the elder people and young people are affected this disease. Since cataract develops gradually, if treated is not received, so can significantly impair the quality of the life, and the result is a total blindness on the age. So it is the problem statement. In the scope of the research workflows, in this methodology we use several methods. First method, we data collection. In the data collection, to collect and organizing the data suitable for cataract detection. It is data type also a image based data, such as fund images, retinal scan, this type of images to collect from Kaggle. Next, data processing. Data processing in the data set to feeding the machine learning model. So we can prepare the data processing. In the processing, resizing image, normalization, data augmentation, splitting the data. First, this type of data processing will be do that data set. Next, the model selection. The in machine learning model in the machine learning In the machine learning, the various type of model is available, but in the cataract eye disease, using a CNN method, only CNN model we use, because is the approach of a image based data. So we use the conventional neural network. And next, the training the model. In the model training, we split the data. In the data set, we split into two types: training set and testing set. Training set equal to 80%, testing test equal to 20%. First, split the data into divided two type: training and testing data. First, to train the model, in the data set, we divided training test and training data and testing data. First, we use the training data. Training data, we use only the model. In machine learning model, we train the data. And hyperparameter training, the adjust learning rate, batch size, number of reviews to optimize the performance in the model training. Next, model evaluation. Model evaluation is a Model evaluation is when the model is trained to evaluate using a test data set. First, in the model, to use the training data, we train the model and we evaluate it using the testing data. You can measure a performance of accuracy, precision, F1 score. This type of classification will be evaluating the model evaluation. Other type is a deployment. Deployment is a deploy the training model to particular platform. Next, the architectural design. In the particular in the particular space, we launch application. The application will be start, and the open front camera, we do the device front camera is activated, detect face and eye. The algorithm detect the user face and locate the eye within the image. We predict cut the two eye only. If the in the image we cut the eye only to show the layout on the camera. If cropped the to eye and display the camera screen, determine the pupil color will be atoms in the algorithm to determine the color of the pupils. If the color of the pupil is a normal eye to match the train the data set. If you match the normal eye, if the crop the tube pupils. And after we purpose in the main purpose in the project, if the matching the existing data set pupil color to match the existing data set, the result will be cataract eye or normal eye. Is in this the architectural design coding. First import the files, and the data set will be also import the Google Colab in the data set to import in this coding. First we split in the data set into two type, training and testing. And the training data set will be considered the split two type, normal eye and cataract eye. It both splitted data, so work on a normal eye and cataract eye. First training path. First, training path will be split the data into insight into the size and balance of the data set, which helpful for preparing for a training machine learning model. Training machine learning model. Next one, the next testing path will be path will be divided inside a balance of the data set and to preparing for a testing machine learning model. Next, the image will be processed on the model. First, normal images and cataract images also to to pre-train the machine learning model. It may and next the scatter plot will be calculate in this project mean values. Next, the next process is the image data generated in the machine learning model. The normal eye and cataract eye to image data generate in this method. And this method will be the image data generator in the in this image data generator. The code will be splitted into the classes. I'm in training and testing data to split in the two classes, normal eye and cataract eye. And next we use in a CNN model architecture. In this output, the CNN model architectures, if split into the many layer, conventional process, max pooling 2D layer, batch normalization, dropout layer, dense layer. It will be um, evaluate this layer and to calculate to predict the CNN model. And next, neural network training process. The training process will be output loss and accuracy for both training and validation test for each epuge. And final result will be epuge is considered the final results also. And the next is the model training metrics. In the model training metrics, to calculate the accuracy, accuracy, value loss. In this in this graph, also predict the loss and value loss in this coding. Next, KNN classification report. In this confusional matrix is a KNN classification report. If classification report provide metric like precision, recall, F1 score, and support for each others. The confusional matrix show a actual value plus predicting count of the each classes. The number of actual conference of the class. occurrence of the class in the data set. To matrix represent the actual value and the predicting outcomes of the each classes. And the predict on the image in the data set. In the training image and testing image will be train and test the model. If the cataract eye in the result, the cataract eye is detect, the binary classification report will be displayed. Cataract means 0, normal eye means 1. In the coding will be consider the predicting cataract eye, the machine learning model prediction. The predicting class is equal to 0. It means the cataract image will be inserted in the coding. So we calculate and the data set into, we insert a cataract image. So we after, in the last process to predict the classes is 0. So the in this coding, the main process is the predicting class of the machine learning model prediction. Is the cataract eye will be 0. It means no. It also a normal eye image to insert a to predict the value is a 1. In conclusion, using machine learning to predict cataract eye disease offer a powerful approach for the earlier detection and interventions in the patient outcome. In the patient of the data sources that machine learning model, particularly those that use deep learning technique like convolutional neural network, can use to uncover cataract related variables. All things considered, machine learning offer a visible path towards predicting earlier detection of the cataract. So it is the useful for the predicting cataract disease. Thank you.